The impact of zero trust on healthcare data. In this video, we discuss what is zero trust, the importance of zero trust in healthcare data management systems, and show a sample demo of a clinical trial data tracking application built on top of Keychain Core, Keychains Zero Trust framework. What is zero trust? Zero trust is an emerging cybersecurity paradigm that aims to provide more control over data security and trust management. Zero trust separates IT architecture from data security, allowing you to maintain data security invariance even as you evolve your IT infrastructure. Zero trust also extends the scope of authentication and verifiability of data to include cloud services, microservices, IoT, edge computing, and offline processing. This removes unaccountable third parties from the trust relationship. Legacy architectures, however, are unfit for purpose as you navigate through the increasingly rapid technology evolution. Legacy architectures have the following shortcomings: fragmented user identity, siloed immobile data that cannot be verified once it exits the silo, data security that is dependent on IT architecture, increasing vulnerability to inside cyber attacks, and a critical reliance on unaccountable centralized third parties such as cloud, network, and certificate authorities. What is the impact of zero trust in healthcare? As a solution provider, you need to provide the best data security solutions for all stakeholders. There are many stakeholders in a healthcare data management system. Technology is moving fast, and healthcare providers need to consider how to keep up with cybersecurity challenges for health data, including identity, data ownership, and protection. But there is an inherent problem in the way healthcare data and identity are managed in legacy systems. And that problem is how to securely transfer data from A to B through an untrusted third-party infrastructure provider, C, and give stakeholders control of access and ownership of medical data. You need to empower all stakeholders to manage data security, regardless of third-party liability capacity or internal security. The zero trust paradigm uniquely enables healthcare technology providers to achieve this in a wide range of use cases. Verification of data needs to happen at every touch point for all stakeholders. Whether it's healthcare monitoring devices, patient input, or input from the person conducting clinical trials, data needs to be authenticated historically and kept private, especially from third-party cloud and network services. Here are 3 examples: data portability, clinical trial data verification, and mitigating cybersecurity risks. For data portability across independent hospital systems, the transporting of X-ray data between practitioners needs to be authenticated and kept secure. In clinical trial data verification, a zero trust framework enables clinical trial investigators to authenticate data, including decentralized trials. And for mitigating cybersecurity attacks, Keychain Core enables dynamic access control in real time. Identity and authentication are challenged and verified every step of the way. A zero trust framework frees you to use new data flow patterns, such as data portability, allowing you to delight your customers while maintaining data security. It also allows stakeholders to normalize their data security and sovereignty risks across geopolitical boundaries. Clinical trial data demonstration. To illustrate the use of zero trust in healthcare, we mocked up a sample application that simulates the transmission of vital signs between a clinical trial participant and a clinical trial investigator. This demo highlights one of several solution accelerators that Keychain provides to its partners. The source code of these accelerators is provided to enable you to quickly build and customize solutions built on Keychain Core, Keychain's Zero Trust framework product. Using Keychain Core, your team will enjoy the control and customizability of in-house development based on easy-to-use, native, composable building blocks. By adopting Zero Trust, you enable customers to independently verify the origin and integrity of data, regardless of the infrastructure used to transmit and store it. In this demonstration that you are about to see, the participant's heart rate data is collected by a stock smartwatch running a keychain-based application. The data is then sent to a tablet through a cloud server, and that tablet simulates a clinical trial investigator. The applications on both devices communicate over HTTPS to and from the server. We will demonstrate the keychain provides data security assurances above that provided by legacy implementations that rely on HTTPS for security. In the event that a hypothetical hacker modifies the data, keychain-enabled systems will detect and filter the modified data, whereas other systems would not. We will show two different modes in this demo, a pass-through mode and a modify mode. In pass-through mode, the data from the participant's watch is sent to the clinical trial investigator's tablet through an untrusted cloud provider. The applications on both devices you see here are built on top of Keychain Core. The clinical trial investigator can verify that the data points, shown here in gray, originated from the participant's watch and that the data has not been tampered with. Next, we will switch to modify mode and demonstrate when data has been modified by a hypothetical hacker. Now, on the clinical trial investigator's tablet, there are red data points being displayed. Those represent data the Keychain Core has flagged as hacked data. This is a key benefit of Zero Trust, the ability to verify the authenticity of the data, the identity of the data creator, and verify if the data is kept private. Without Keychain, the clinical trial investigator has no way to verify if the data they are receiving has been altered. This puts the integrity of the clinical trial and the participant's medical data at risk. Now, switching back to pass-through mode, we see that the data is once again verified as authentic, as indicated by the gray color. To recap this demonstration, we showed you two modes, pass-through and modify, in which Keychain was able to verify data. HTTPS is known not to be able to verify data in the modify case. Simply put, legacy systems have no way to verify data that has left the network, and therefore restricts the type of data flows you can implement securely. Keychain, on the other hand, helps you solve this problem and empower all stakeholders to manage data security. In this presentation, we showed you what Zero Trust means and its ability to provide tamper evidence and privacy in data. We covered the limitations of current solutions for all stakeholders in the healthcare data ecosystem and the importance of integrating Keychain Core, a Zero Trust framework. We also showed you a sample application built on top of Keychain Core, demonstrating clinical trial healthcare data being sent from a patient's IoT device to an investigator's tablet with data verification. This level of security and authentication is needed in all healthcare data scenarios. As a system integrator and solutions provider, you can leverage Keychain Core, a Zero Trust framework, to build easy-to-integrate applications and solutions, and enable all stakeholders in the healthcare ecosystem to protect and verify data. Reach out to us today to learn more about Keychain and to see how you can bring the best data solutions to your customers in the healthcare sector.